Pop quiz. What happens when you suck helium from a balloon and talk? You already know. Your voice goes all high and squeaky like a cartoon chipmunk on Fast Forward. Everyone laughs. It is probably the most famous party trick in the world. But here's the thing that might blow your mind. Helium does not actually raise the pitch of your voice. Not even a tiny bit. Your voice stays at the exact same pitch it was before. So if helium is not making your voice higher, what on earth is it doing? To figure that out, we need to understand something surprising about how your voice actually works. Let us start with the basics. Sound is a vibration. When anything shakes back and forth, whether it is a guitar string, a drum head, or your vocal cords, it pushes and pulls on the air around it. These pushes create waves of pressure that ripple outward in every direction, kind of like the ripples you see when you drop a stone into a pond. When those pressure waves reach your ear, tiny bones and membranes inside decode the vibrations, and your brain interprets them as sound. The faster something vibrates, the higher the pitch you hear. The slower it vibrates, the deeper and lower it sounds. Your voice starts deep inside your throat, at two small flaps of tissue called your vocal cords. When you breathe normally, they are relaxed and open, letting air flow silently through. But when you want to speak or sing, muscles pull them together, and as air from your lungs rushes past, they start vibrating rapidly. How fast they vibrate depends on how tight they are stretched. Tighter cords vibrate faster, giving you a higher pitch. Looser cords vibrate slower, giving you a deeper pitch. For most adults, these tiny flaps vibrate somewhere between 85 and 255 times every single second, just to produce normal speech. That is an incredible workout for two tiny pieces of tissue. But here is the thing, your vocal cords by themselves sound terrible. Seriously, if you could somehow listen to just the raw buzz they produce, it would sound like an annoying electric razor. Nothing like your actual voice. The real magic happens after the sound leaves your vocal cords and travels upward through your throat, your mouth, and your nasal passages. This entire tube of space above your vocal cords is called your vocal tract, and it works exactly like the body of a guitar. The strings of a guitar produce vibrations, but it is the hollow wooden body that gives the sound its warmth, richness, and character. Your vocal cords are the strings. Your vocal tract is the body of the instrument. This brings us to one of the most important ideas in all of sound, the difference between pitch and timbre. Pitch is simply how high or low a note is. Middle C is a pitch. A high whistle is a pitch. But timbre is the quality or color of a sound. A piano and a trumpet can both play the exact same note, hitting the exact same pitch. But you would never confuse the two, would you? They sound completely different. The piano sounds warm and resonant. The trumpet sounds bright and brassy. That unique character, the thing that makes each instrument recognizable even when playing identical notes, is called timbre. And just like every instrument has its own timbre, so does every human voice, shaped by the unique size and shape of your vocal tract. Now here is where things get interesting. Your vocal tract amplifies certain frequencies of sound more than others, based on how long the tube is and how fast sound travels through it. These natural amplification points are called formant frequencies, and they are what give your voice its unique signature. In regular air, the kind you're breathing right now, sound travels at about 343 meters per second. That is roughly 770 miles per hour. Your vocal tract has evolved over millions of years to produce beautiful, recognizable human speech at exactly that speed. Every frequency that makes your voice sound like you is perfectly tuned for sound moving through ordinary air. But helium changes everything. In helium, sound does not travel at 343 meters per second. It rockets along at nearly 1,000 meters per second. That is almost 3 times faster. Imagine you are in a swimming pool, gently making waves with your hand. The waves leave your hand at a steady rhythm, rippling across the water at a predictable speed. Now imagine the water suddenly becomes 3 times thinner and less dense. Your hand is still moving at the exact same pace, but the waves it creates zip across the pool nearly 3 times faster. The source has not changed, but the medium carrying the waves has transformed completely. Why does sound travel so much faster in helium? It all comes down to weight. Regular air is mostly nitrogen and oxygen, which are relatively heavy molecules. The average air molecule weighs about 29 atomic mass units. Helium atoms, on the other hand, weigh only 4 atomic mass units. That makes them over 7 times lighter than a typical air molecule, and lighter particles can bounce around and transmit vibrations much more quickly. Think of it like comparing a bowling ball to a ping pong ball. Flick them both with the same force and the ping pong ball flies away instantly while the bowling ball barely moves. Helium atoms are the ping pong balls of the gas world, and they carry sound incredibly fast. So when you fill your vocal tract with helium instead of air, sound suddenly zips through that tube nearly 3 times faster. And because the resonant frequencies of any tube depend on how fast sound moves through it, all of your formant frequencies shift dramatically upward. The harmonics that normally make your voice sound rich and full suddenly jump to much higher frequencies. Your vocal tract is still the exact same size and shape it was before. Nothing about it has physically changed. But because sound is racing through it at triple speed, the tube resonates as if it were much smaller. It is like taking a big church bell and making it ring as if it were a tiny bicycle bell. And here is the part that surprises everyone. Your vocal cords have not changed at all. They are still vibrating at the exact same frequency, producing the exact same fundamental pitch they always do. Helium does not touch them. It has no effect on how fast they vibrate. The only thing that changed is the gas filling the space above them in your vocal tract. So the pitch of your voice, the actual musical note your vocal cords are playing, stays completely identical. What changed is the timbre, the color, the character. You are playing the exact same note on a completely different sounding instrument. Same singer, same song, wildly different concert hall. This is exactly why a helium voice sounds so hilarious. It is not that everything simply got higher, it is that the normal balance of harmonics in your voice got completely reshuffled. The lower harmonics that normally give your voice warmth and depth suddenly get pushed aside, while higher harmonics that you usually barely notice become the dominant ones. Your brain instantly recognizes the voice as human, but it also knows something is very wrong with it. There is this mismatch between what your brain expects a human voice to sound like and what it is actually hearing. That gap between expectation and reality is exactly what triggers laughter. Your brain is essentially saying, that is a person, but that is not how a person should sound. Now what if you could go the opposite direction? There is a gas called sulfur hexafluoride that is about 5 times denser than regular air. It is so incredibly heavy that you can actually pour it from a container like an invisible liquid, and lightweight objects like tinfoil boats will float on top of it. When you breathe sulfur hexafluoride and speak, sound crawls through your vocal tract at only about 134 meters per second. That is less than half its normal speed. Your formant frequencies shift way down and suddenly your voice drops to a deep, rumbling growl. You sound less like a cartoon chipmunk and more like a movie villain. Before you rush out to try either of these party tricks, there is something really important you need to know. Both helium and sulfur hexafluoride are not toxic, but they are not oxygen either. When you breathe them in, they take the place of the oxygen your body desperately needs. If you displace too much oxygen, you can get dizzy, pass out, or in extreme cases, it can be fatal. Sulfur hexafluoride is especially tricky because it is so heavy that it sinks to the bottom of your lungs and can be very difficult to clear out. A couple quick breaths from a party balloon is usually fine, but never breathe directly from a pressurized tank, and always take plenty of normal breaths in between. This relationship between the speed of sound and resonant frequencies shows up everywhere in music too. A flute player performing at high altitude where the air is thinner will be slightly out of tune compared to sea level. Pipe organs in different climates need regular retuning because even small temperature changes affect how fast sound moves through air, which shifts their pitch. Every wind instrument depends on the speed of sound to determine which notes it plays. Your vocal tract is just one more resonating tube, governed by the exact same physics as a clarinet or a trombone. The science behind a silly helium party trick turns out to be the same science that makes orchestras sound beautiful. So the next time someone sucks helium from a balloon and everyone bursts out laughing, you will know what is really going on. Their vocal cords never changed speed. Their pitch stayed exactly the same. What changed was the medium their sound was traveling through. and that completely transformed how their vocal tract shaped the sound. Same vocal cords, same note, completely different instrument. Helium did not raise their voice. It rebuilt the entire acoustic architecture of their body from the inside out. And honestly, understanding the real reason is way more fascinating than just thinking, the gas makes everything go up. Sometimes the most familiar things in the world hide the most surprising science. If you like this video, check out one of these, and don't forget to subscribe.